Welcome to this explainer. Look, if you're managing, designing, or even just using enterprise infrastructure today, you already know the ground is shifting right under our feet. Today, we're unpacking a fascinating set of insights about the true impact of artificial intelligence on our networks. And let's get one thing straight right out of the gate. AI is no longer just some novelty app sitting in the cloud. It's a massive, infrastructure-altering workload that is completely rewriting the rules of network demand.
Okay, let's dive right into this because 25 to 30%, that is the sudden traffic spike we're looking at as AI adoption scales up. That should be a serious wake-up call for any IT leader. We're looking at an immense, rapid surge in volume that traditional architectures simply were not built to handle without severe bottlenecks. So, how do we survive this surge? Here is our roadmap for today's explainer. We'll start with why AI is the new workload. Look at traffic volume and shape, explore how the network becomes an AI fabric, dive into zero-trust security, tackle data debt, and finally, lay out a practical roadmap for leaders. Let's get into it.
Section 1. AI is the new workload. It's truly becoming the core business engine.
We really have to fundamentally shift how we think about this technology. It's moving from just a handy tool you use to the actual engine running the business. And AI's impact? It touches absolutely everything. One minute it's internally focused, the next is external, but it is always security focused. Network teams are suddenly being forced to support heavy model training, real-time inference, and complex collaboration copilots, all at the exact same time. It's totally altering our baseline performance expectations.
Moving on to Section 2, traffic volume and shape. We need to move way beyond flat averages here.
We know the total volume is jumping 30%, but honestly, the shape of this traffic is the real problem. In the past, network planning relied heavily on flat averages. Find a historical baseline, tack on a little buffer, and call it a day. But relying on averages for AI? That's like using average daily traffic to plan for a total rush hour highway closure. It just doesn't work. AI creates massive, totally unpredictable spikes that are tied to highly specific edge locations, specialized projects, and strict security postures. So what looks like a normal day on average might actually be a day where a localized GPU cluster completely chokes out a specific network segment.
To survive this, we've got to look at flow directions. Training these AI models requires massive east-west syncs. We're talking heavy, high-bandwidth data moving laterally between accelerators and platforms. Meanwhile, everyday AI inference creates these constant, rapid north-south flows from users to models and back again. Because of this intense, dual-directional strain, it is absolutely crucial to map and tag every single flow by its function, priority, owner, and failover path.
All right, Section 3. The network becomes AI fabric. We're talking about an active performance fabric now.
Look, if you're tagging flows at that granular level, your network can no longer just be passive, dumb plumbing. We need new operational bridges, specifically things like AIOps and self-organizing networks, or SON. And what's really fascinating here is that these aren't just industry buzzwords. They are vital technological systems. They actually learn normal behavior, catch anomalies way before they cause outages, and dynamically adapt network paths, capacity, and policies on the fly to meet AI's intense demands.
Let's see how this actually builds in action. It's essentially a continuous loop. The system takes in massive amounts of data, aggregates it, and then applies AI to detect anomalies and trigger intelligent alerts. But the real magic happens when we get to automated remediation and performance optimization. Think about it. Your network is essentially using AI to manage the network for AI. That is how you ensure the fabric remains resilient under these extreme loads.
This leads us to a pretty profound realization that completely changes how we measure success. Network performance is now a core part of AI quality. Seriously, think about it. You could deploy the absolute most powerful, brilliant language model in the world, but if the network path delivering its answers is congested or suffering from high latency, the end user is just going to think the model itself is slow, weak, and ineffective. The user's perception of quality is entirely dependent on the health of that whole transit path, not just the model sitting at the end of it.
This brings us to Section 4, Zero Trust Security Controls. And the theme here is secured by default.
You really can't have a healthy transit path without a secure one, and those old perimeter defenses, they just won't cut it anymore. Now, what's really interesting about this absolute language, the idea that security is not optional, is how it redefines our priorities. Unlike past tech trends, where security was often, let's be honest, bolted on as an afterthought, AI networks must be secured by default, literally from day one. These systems are touching your most sensitive data and executing automated actions, making the stakes incredibly high.
This mandates a strict zero-trust model. We're talking comprehensive identity governance, tight micro-segmentation, and deep traffic inspection. Every single endpoint, API, and model needs explicit access boundaries. Absolutely nothing is trusted by default, whether it's inside or outside your corporate firewall. And to maintain this posture, you need rigid, quarterly assurance checks to guarantee these controls are evolving exactly as fast as the AI itself is.
Implementing all this is definitely a journey, mapping out cleanly across 4 quarters. Quarter 1 is all about building visibility, deploying telemetry-capable switches to actually measure those baseline east-west flows. By quarter 2, you're implementing that zero-trust mesh with microservice identities. Then quarter 3 introduces autonomous defenses, like reinforcement learning honeynets. And finally, in quarter 4, you achieve continuous assurance. This is where you're using digital twin integrations to test risks before they ever even touch your production environment.
Section 5. Data debt equals network debt. This is the hidden pipeline liability we need to talk about.
Once your security is locked in, we really have to look at what's actually flowing through those pipes. The contrast here is stark. On one hand, you have rapid development without data cleanup, which results in this leaky, fractured pipeline, creating massive bottlenecks and just burning money. Contrast that with the optimized zero-trust path, where software-defined networking and observability keep data flowing cleanly and efficiently between clients, AI agents, and tools.
The harsh reality is that bad data hygiene actively destroys your network bandwidth. It's literally like putting contaminated gas into a high-performance sports car. The cost of bad data isn't just a database issue anymore, right? It wastes precious network capacity, it burns expensive compute cycles, slows down enterprise decision-making, and ultimately degrades user trust in AI. Major hidden liability alert here. Data quality problems literally become AI performance problems.
Finally, Section 6, a roadmap for leaders. How we achieve sustainable AI adoption.
So the crucial point is, how do we actually execute on all of this? Here is a practical 4-phase blueprint for sustainable adoption. Step 1, foundations first. Gather your inventory, establish telemetry, and really map your traffic. Step 2, people and process. This takes cross-functional roles and a strong culture of governance. Step 3, security in the loop, which means actually implementing that zero-trust segmentation we just discussed. And finally, Step 4, data debt and playbooks. Clean up your assets and use real-world playbooks to test before you scale, so you avoid ending up with just another isolated, doomed pilot project.
As a leader, your strategy here must be incredibly proactive. Please, do not wait for a catastrophic network overload before you redesign your capacity and operating models. You need to conduct comprehensive readiness assessments across compute, network, storage, and data governance right now. Embrace iterative deployments with very clear monitoring and rollback options. Break down those silos by building cross-functional teams, and aggressively foster internal AI literacy. Your human workforce has to evolve right alongside this tech.
Which leaves us with one vital question to ask yourselves and your teams today. Are you purposefully building an intelligent, secure AI fabric, or are you just sitting back, waiting for your legacy plumbing to break under the pressure? Because that 25 to 30% traffic surge, it's coming. The time to architect your network for the AI era is right now. Thanks so much for joining me on this explainer, and I highly encourage you to take these strategies back to your teams and start future-proofing your systems today.